Okay, we're taking notes on 11.3, slope and intercepts. Alright, so first we're going to just identify the different types of intercepts. The one that we will most often use are the x-intercept and the y-intercept. So x-intercept. The x-intercept is when, let's cross that out. Value of x when line crosses x-axis. That would be when y equals 0. So when y equals 0, that's when you are going to get a coordinate point of some x value and 0. The other one is, of course, then y-intercept. Where the value of y, where the line crosses the y-axis. This is going to be when x equals 0, so you're going to be working with the coordinate points of 0 and then some point for y. So an example of how this might look on a graph. Real quick, let's just sketch a graph like this. I'm going to just use really informally 1, 2, 3, 4. Let's say 4 tick marks and then 1, 2, 3. Okay. So if I put a point here, and then I put a point 1, 2, 3 here, my coordinate points are, for this, it's going to be 4, 0. For this one, it's 0, 3. And we said that when the x-intercept is when it crosses the x-axis, so right here. So this point is what we are looking for as the x-intercept. Oh, I can't even see that. Okay. And this point up here, where it crosses the y-axis, that's what we call the y-intercept. So how do we find these important intersections? Well, so that's going to be our point 1. Okay, I'm going to adjust the camera. This is just too hard to work like this. Let's see if this works. Okay. So our first thing that we're going to work out today is finding the x and y intercepts. So let's say, for example, we have the equation, and we've been talking a lot about linear equations. We have the equation 2x plus 3y equals 6. Remember that a linear equation means that when I find all the solutions for x and y that work for this solution, it's going to create a straight line. That's why we're calling this a linear equation. To find the x and, so we'll do this in two parts. This side we're going to say finding the x-intercept. And this side is finding the y-intercept. We said before that an x-intercept is when when y equals 0, and you find the y-intercept by seeing when x equals 0. So to find the y-intercept, and we're saying to find the x-intercept, we're saying y will then equal 0. So let's go back to our original equation that we're looking at and plug in what we know. We don't know x still. We do know that the y is going to be 0, so I'm going to plug that in for y. Go ahead and solve for x. So let's go ahead and simplify this. So now we get x equals 3. So that means our x-intercept lies where we have the coordinate points 3, 0. In the same way, when you find the y-intercept, we're going to do exactly the same thing. Use that original equation, except now plug in 0 for x. So we have 2 times 0 plus 3y equals 6. 2 times 0 is 0, so that's gone. 3y equals 6. Divide each side by 3. And that's why you're going to end up with y equals 2. Meaning the y-intercept falls where we have the coordinate points of 0, 2. And that allows us now to graph this. And since we know 2 points on it, that allows us to create that line of solutions. So we have, let's say, 1, 2, 3, 4, and 1, 2, 3, 4. Put a dot where it's 3, 0, 1, 2, 3, 0, 2, so you don't go left to right, just go up 2. So now we have these points. And let's see if I can get a straight edge. There it is. If I connect those two. There you go. So 2x plus 3y equals 6. That equation creates this line of solutions. We'll be doing more practice problems like this tomorrow, so just want to make sure you have the notes and you understand the concepts, and then we'll actually practice them together. Okay, so the second part today then is using the slope-intercept form. The slope-intercept form is, what we're doing is we're taking an equation that might look like this, and we're going to switch things around and find in terms of y, and that's going to give us a lot of good information that will help you graph quickly. So the main point is to make an equation that looks like this, because when you do, now you have some important points that you can use to graph this equation. So I'm going to put a bubble around here. It's really important. And then let's identify some of these features. X and Y, of course, are coordinate points like this. These are different solutions. But then this M that we see here stands for the slope. And then this B that you see here, that tells me where the y-intercept falls. So when the line crosses over the y-axis. Because now I'm going to see that once I have an equation that looks like this, and I have a number for slope and a number for the y-intercept, you're going to later see that that's going to make it so much quicker to graph it on a coordinate grid, because you're going to know exactly where it falls on the y-axis. And then from that point, you can go up and down and side to side, rise over run, using the slope that you found. So here's our first example. So example A. Let's say you have an equation that looks like this. Y equals x. And we talked about that in terms of slope. This can be identified with the slope-intercept form because I have the y, that's still the same. I have x, there's nothing in front of it. So some people might say, oh, there is no slope, but there is, because x is going to be the same thing as 1 times x. So that tells me that my slope is 1 plus, and there's nothing here, which means that I can say plus 0, and this equation is the same as this equation. So now here we go. We have the same form as the slope-intercept form, meaning that I could quickly graph this, and I can identify the slope as being 1 and my y-intercept being 0. And remember before we said the y-intercept is where if that's a value of y, that means that it crosses the coordinate point there. So let me show you how quickly I can graph that. So y equals x, that means that so it crosses over at 0, 0. And since our slope is 1, that means I'm going to go up 1 over 1. Up 1 over 1. Up 1 over 1. Until when I point. So there's what my y equals x line is going to look like. And that's true because look at this point right here. This point is 1, 1. If I took that and plugged this back in here, and I say the y value is 1, and that equals the x value, which is 1, which is true. 1 equals 1. Let's go on then to a little bit more complex example. So here's example B. And you might have something like 7x equals 3y. And we're trying to get this into the form of the slope-intercept form, which is y equals mx plus b. So ultimately, your focus should be, how can I change this to get it in terms of y? We've been practicing this for a while. So first thing we're noticing, okay, well, to get y by itself, I just have to divide both sides by 3, which then cancels this, and I get left with y. And over here is 7 over 3. And there's your x. And just like in the previous problem when we didn't have a b value at this point, I'm going to just switch this around to make it look like this. So I have y equals, here's the number that's next to the x, plus, we don't have b in this, but we know that just means that it has an y-intercept of 0. So what this tells me is that my slope, that's what m equals, and then my y-intercept, my b, equals 0. And once we have that, that's so easy to graph, because 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Because my y-intercept is 0, so you're going to be intercepting at 0. There. And my slope then tells me how much I need to go up. Remember the top value? The top number tells me how much I need to go up or down. And the bottom number is run, how much I need to go side to side. So from this point, I need to go up 7. 1, 2, 3, 4, 5, 6, 7. And then over 3. 1, 2, 3. And once I connect those lines, at those points, that means every point on this line, whatever x, y I get, will work for this equation. I'm going to give you one more harder one to work through with me. Here's example C. So what if we have something like 2x plus 5y equals 8? It's really similar to kind of like the first problem that we started with over here. So when you have an equation that looks like that, again, you're thinking, okay, how can I rearrange things so that I can solve it in terms of y? Don't forget the rules and the order of operations that you have to follow. So first thing I'll do is put this 2x over to the other side. I can do that by subtracting 2x here. So now I have left 5y equals, here's 8, and then minus 2x. I'm going to divide everything then to get y by itself by 5, and you end up with y equals, and remember when you can simplify this and it's divided by 5 and it's connected with like an addition or subtraction, then I could split that apart actually, because that's a common denominator, and this is the same thing as doing 8 over 5 minus 2 over 5x. At this point, we're still kind of not at that slope-intercept form because we're just saying that the slope and the x comes before the y-intercept, so then switch things around. My only really big advice and warning to you is don't lose that negative. So a lot of times it's easier to kind of change things to an addition problem so that you don't lose that negative somewhere. So now if I switch it around to make it look like this point's slope-intercept form, it's going to look like y equals negative 2 over 5x plus 8 over 5. Okay. A confusing point right here is people tend to, I'm going to carry this up here and show you something here. Having negative 2x over 5 is the same thing if I did negative 2 over 5 times x over 1. Isn't it? Because all you're going to do is multiply across and you end up getting negative 2x over 5 times 1. So then all I'm doing is pulling this x out, and that's why we get to see this mx form by saying this is 2 over 5 times x. In other words, when we multiply a variable and a coefficient, you don't even need to use that multiplication sign, which is why we end up with that. Oops. Okay, so all of these things are the same form. That's how I ended up getting it to look like this. Now, I'm going to just show you one practice problem, and I just want you to look through this, take notes on it, and then in class we're going to actually try some examples together. So part 3 of today will be how to write slope-intercept form. And when we say slope-intercept form, of course, then we're looking for the slope, and then we're looking for the y-intercept. And we had already talked about how that looks like y equals mx plus b. Obviously, since I keep saying this over and over again, it's a really important, I guess, form to remember. So let's say I want you to find the slope-intercept form using, and I will only give you 2 points. I give you the points negative 3, 1, and 2, negative 1. Now these aren't just any two random points, but these are 2 solution points on that line, meaning these 2 points fall on the line. So I have 1, 2, 1, 2, 3. So if these 2 points fall on the line, what I'm asking you to do is to find out what is the equation of this line. And I want you to find the equation, write the equation in the slope-intercept form. So, first thing I notice when I look at this is to make things easier, I'm going to label this. I'll consider this my x1, I'll consider this my y1. I'm going to consider this my x2 and consider this my, y2. Okay. Just like it says, we're looking for the slope and the intercept. So how would you find slope using these 2 points? And we did this yesterday in our notes. You're going to use that slope formula of y2 minus y1 over x2 minus x1. And again, I just picked randomly which ones I'm calling x1, y1, and which one I'm calling x2, y2. I could have totally called this x2, y2, and this x1, y1, and even if you plugged it in like that into this formula, you're going to get the same slope. So here, I'm going to just take each of these points, plug it into here, and I get -1 minus +1 over 2 minus -3. At this point, I don't want to be mixing up or losing any negatives, so I'll go ahead and change these. Change. And I end up getting a slope of -2 over +5. So here's my slope, or what we call our n. Okay, so we're halfway there. Next, then, we need to find that y-intercept. Remember in the beginning of the lesson, we talked about how would you find the y-intercept? We find it by saying that when is x equal to 0, you're going to see where the y-intercept falls. So let's go back. I'm going to use this formula, the slope-intercept form, y equals mx plus b. We already found the slope, so I'm going to plug that in for m. So I end up getting y equals -2 over 5 times x plus b. When we're looking for the y-intercept, what we are looking for is this b. Okay, that's what we're not going to know. Everything else we should know. How? Because we're saying you're going to now try to figure out what b would be. So then we need to plug something in for y and x, because we can't figure out a equation when we have so many variables. Well, what's helpful is that I gave you 2 points to look at. So just pick one of those points, because in each point you have an x value and you have a y value, so it's going to work out. So I'm going to go ahead and pick, let's say, -3, 1. So using the point -3, 1, now I'm going to use -3 as my x value. I'm going to use 1 as my y value and plug that into this formula. So for y is 1, -2 over 5 times -3 plus b. So now we only have one variable and we're trying to find what b equals. So here I get 1 equals negative times a negative is going to give me a positive. 2 times 3 is 6 over 5 plus b. To get b by itself, I'm going to subtract 6 over 5 here, subtract 6 over 5 here, and you end up with -1 over 5 equals b. So now you have the 2 important portions of a slope-intercept form. We found the slope here, and then we found the intercept here. So now let's put that into our y equals mx plus b format. We're going to leave y because we're saying, y and x you don't fill in numbers for, because that's going to be part of our line equation. For slope, we said is -2 over 5 x plus, and we just found that the b was -1/5, so we're going to say plus -1/5. Or we might say y equals -2/5 x minus 1/5. Same thing. Okay, get these notes down and then we'll practice using these concepts in class.